In this video, we're going to look at the limit of an absolute value function. Here we're looking at the function absolute value of x divided by x, and we're looking at the limit as x approaches 0. In order to find this limit, we are going to look at the graph of this function f of x. In order to graph the function, let's first review how the absolute value of x behaves. If I take the absolute value of x and x is a negative number, the absolute value makes that negative number positive. But if x is positive, it's just going to leave x as it is. So we can define the absolute value of x as a piecewise defined function. That just means that there's a different rule that our function follows for different values of x. And I'll write that like this. So whenever x is less than 0 or when x is negative, the absolute value makes the value positive. In order to make a negative positive, I just have to introduce another negative. So here, whenever x is less than 0, the absolute value is going to be the negative of x. And then if we look at x greater than or equal to 0, so for 0 in all positive numbers, the absolute value will just leave the value the same. It's just going to be equal to x. Now let's use this in order to simplify our function f of x. We're also going to rewrite f of x as a piecewise function. We can plug in negative x for the absolute value of x. We keep divided by x. And this is the case when x is less than 0. And then we can replace the absolute value with just x. We leave the divided by x when x is greater than or equal to 0. We can simplify this one step further because x divided by x will leave me with 1. So here I can rewrite my function as f of x is equal to negative 1 when x is less than 0, and it will be equal to positive 1 when x is greater than 0. But let's stop for 1 second. What happens when x equals 0? When x equals 0, the value of my function will be equal to x divided by x, which would be 0 divided by 0. When my function is 0 divided by 0, that is undefined. So my function is undefined. It does not have a value when x equals 0. For every other x value, the x's will cancel and simplify to be 1, but we do have to leave off x equals 0 because it's undefined. Now that we've done this, we can easily graph our function. Let's go ahead and draw our coordinate plane. And here we see that whenever x is less than 0, the value of my function is negative 1. So I have this horizontal line here, and I'll draw a hole because we're not including 0. And then also, whenever x is greater than 0, the value of my function is 1. I have this horizontal line, and again, I'm not including 0, so I have this hole here. Now that we've drawn our graph, let's go back to our question. So we're looking at the limit as x approaches 0 of my function. For looking at the limit as x approaches 0, we want to know what is the value of my function approaching as I get really close to 0 from the left and the right. So let's trace along our function from the left of 0, and I see that the value of my function is approaching negative 1. And then if I am tracing along my function from the right of 0, the value of my function is approaching 1. Since the value of my function is not approaching the same value from the left and the right of 0, that tells me that my limit does not exist.